So here's a sinusoidal function, right? We're introduced to these on Friday, and what we'd like to do is, given this graph, let's figure out the equation. Okay? So remember the characteristics. Our equation is of the form y equals a sine bx plus c plus d. And the first thing I usually like to figure out is where is the midline, right? And the midline is, bless you, midline is which of these letters? Which one of these guys is the midline? D. Okay. So midline is just the average, right? So we have a maximum. This is a maximum value, and we have a minimum value, and the midline is halfway in between those numbers. How do we find the midway point of two numbers? Yeah, we just average them, right? So what's the average? So we have a maximum value of, what's this? 5, and we have a minimum value of 1. So D, we go over here. D is equal to max plus min divided by 2, which is 5 plus 1 over 2, which is 3. So D is equal to 3. And oftentimes, if I'm doing this kind of stuff, I like to draw the midline in. So let's just draw it in. That should be a straight line, right? It's almost sinusoidal. So there's our value for D, right? We've calculated D, so we got this one done. Amplitude, what's the amplitude? How high? Well, it's the distance from here to here. There's another way that we can do that. It's half of the distance between max and min. To get the distance between max and min, so the amplitude is max minus min over 2. Right? I mean, if you remember back to when you're doing coordinate geometry, you want to find the distance between 2 points. You took the maximum value minus the minimum value. That tells you how far apart they are. And we're halfway, right? The definition of amplitude. So the max is 5, the min is 1. 5 minus 1 over 4 is 4 over 4. Wait a sec, sorry, over 2. 4 over 2 is 2. Okay. So from the maximum and the minimum, we can get the midline and we can get the amplitude, right? Those are the two easy numbers. Next up, we want to figure out the period. So the period is any number of things, right? The period can be from a minimum back to a minimum. Remember, the period has to cover all 4 parts of the function. The function has 4 parts, right? Midline to max, max to midline, midline to minimum, highlighting everything, and minimum to midline, and then midline back to maximum, right? So there's 4 parts. So those 4 parts can go from here to here, right? From the middle to the max, to the back to the middle, to the minimum, back to the middle. This will be 1 period. From the minimum to the minimum is 1 period. From a maximum to a maximum is 1 period. So we could take any of those points. Probably the easiest is going from the minimum to the minimum, because this minimum is at 0, right? So we don't have to do any further calculation. It goes from 0 to, okay, we got what, 2.5, 3, a little bit over 3. So what do we say that would be if it's a little bit over 3? We'd say it'd be pi, right? Pi radians, 3.14. So a little bit over 3. So our period is pi. So period is equal to pi radians. Now you are given a formula on your formula sheet, right? So remember, A and D are easy to figure out, right? But B, the formula you're given is period is equal to 2 pi over B. So you're given this formula. Period equals 2 pi over B. We know the period is pi, so we'll go pi is equal to 2 pi over B. And so we'll just cross multiply, get b pi is equal to 2 pi, so b is equal to 2. So we got that, and now we've got this. So we have a, b, and d. Now, to figure out c, what we're looking for is the starting point of this function. And this point is here. This is defined as the start point. So where is that start point? What you do is you look along the midline until you find the function intersect the midline and it's going up. And that is defined as the start point. So what you do is, having drawn the midline in, we just sit there and we go along the midline. You can go either way really, but might as well go to the right. So we go along the midline until we find the function and it's going up. So, you know, if this were here, this is going down, right? At the midline, this intersection, we're going down. So we look for the midline going up. We figure out what this value is. Okay, and it's around, what do we got here? So that's 1. So that's half. So what I'm going to do is give you the formula for start point. I just don't know if I'm going to do it on here. It's not a lot of room. Let's see if we can move stuff. And I can move the function. Okay, I'm going to squeeze it in over here. Start point is equal to negative c over b. Okay, negative c over b. So we already have a, b, and d. If we can figure out this start point, now we really aren't responsible for getting the c value. Okay, so let's just be aware there is some value of c here, because the c we know shifts the curve left and right. We're not responsible for figuring it out, so we're not going to. So we're going to look at this. We said that a was equal to 2, so we have y equals 2 sine. We said that b was equal to 2, so it'll be 2x plus c. And the d value was 3, so plus 3. So 2 sine 2x, so let's take a look at it. So there's the equation. 2 sine 2x minus pi over 2 plus 3. Right? So we were able to figure out a, b, and d given all of the information that we had. So this is what we're looking for, right? We're looking for maxes and mins. So this is given the graph, right? If I give you a graph, you find the max, you find the min, you use that to calculate the midline, you use that to calculate the amplitude. You get the period from the graph. You just have to look at the graph, find the distance, right? It's the x distance from a minimum to a minimum, a maximum to a maximum, or the midline all the way through one cycle. Okay, so hang on, I'm just going to pop. So given the formula in this form, the equation of the midline is maximum plus minimum over 2. The amplitude is max minus min over 2, or the distance from the midline to either the min or the max, right? So if you draw that midline in, you can just count sometimes. Period, the length of the interval of the domain to complete one cycle, that is the length of one cycle. If the equation is given, you've got this formula, and this is on your formula sheet. Or 360 degrees over b, so you might use that a little bit in the book. The book might have some stuff in degrees. We will almost always use 2 pi over b. Okay, we use radians, so your calculator most times is going to be in radian mode. Start point is where the graph intersects the midline. It's first going up. It's negative c over b, comma d. All right, applications. So this is really what it's all about, right? This unit. It's not about doing it in degrees or doing it in radians. It's about, hey, here's a Ferris wheel. Graph below represents the height of a person on a Ferris wheel over time. The person gets on the Ferris wheel at x equals 0, that is the time is 0 and y is the height. So this is height of the wheel or the person, and this is the time. Running along here, and I believe it's measured in minutes. Because if it were seconds, that thing's moving pretty fast, so yeah, it's got to be minutes. So, what's the height of the Ferris wheel when the person first gets on it? How high is it? 2 meters, right? So it's down here. 2 meters. What is the minimum height of the Ferris wheel? What's the lowest it goes? Also 2 meters. What's the maximum height of the Ferris wheel? How high does it go? 82. What's the equation of the midline? Yeah, so D is max plus min over 2. What's our max? 82. What's our min? So that's 84 over 2, which is 42. So the equation is y equals 42, which means the value of D is 42, right? Well, we've got that. D equals 42. And the equation of the midline then is y equals, right? So let's draw that in on our graph. It's always handy to be able to see the midline. So that's at 42, so we're just going to sketch a line along here. Right. And over here I'm just going to write D equals 42. Doesn't seem very colorful today. What is the amplitude of this sinusoidal function? So we can do this 2 ways, right? We can go to the graph and we can count the distance from here to here or from here to the bottom. But we've got max and min, so it's probably easiest just to use the formula. So A is max minus min over 2. You're not given this formula, right? The only formula you get is period equals 2 pi over b. Anything else, you know, if you want to remember it, amplitude is max minus min. So it's 82 minus 2 over 2, which is 80 over 2. So A is 40. And it's actually meters, just the same as D is really 42 meters. Okay, so the amplitude of this function is 40 meters. Okay, so D is equal to 42 meters. And the reason is that A and D are actual physical characteristics of the Ferris wheel, right? They describe stuff about it. So what is the radius of the Ferris wheel? Actually, I should ask one other thing, which I didn't put in here. What does the midline represent? Let's throw that in here. What does the midline represent? What does the midline represent? It's in the middle of the Ferris wheel. What's in the middle of a Ferris wheel? Or a car wheel? Or a bicycle wheel? It's in there. It's the axle or it's the hub, right? So you've got an axle, your wheel goes on. Right, that's what this is. So the midline represents the height of the axle or hub of the Ferris wheel, right? Physically, it's that point that's in the center, right? There's this pin that runs through there, and the whole thing rotates around this axle or pin, just like a bicycle wheel or a car wheel or anything else, any other wheel. Okay, what's the radius of the Ferris wheel? What is it? So if D is the height of the hub, then which one of them represents the radius? Where would you measure the radius? Where would you have to go on the Ferris wheel to measure the radius? From the center to the top or the bottom. Which one of these letters measures from the center to the top or the bottom? A. So the radius of the Ferris wheel is 40 meters, right? It's the amplitude. Right, Because the amplitude is the distance from the midline to the max or to the min, which on a wheel is the radius of the wheel. What's the height of the person after 1 minute? 40 meters? How long does it take for one revolution of the Ferris wheel? 4 minutes? How did you find that? Well, hey, if we're starting at the bottom, when we get back to the bottom, we'll have gone around one time. That's 4 minutes. What is the period of this sinusoidal function? Minutes. Period is the length of one cycle, right? It's the time it takes to get around once on the Ferris wheel. So a lot of what we're doing is relating the physical characteristics of whatever we're examining to the equation, right? Trying to figure out, so, what does D represent in this context? What does A represent in this context? What's B? What is B? So we have a formula, right? Our formula is period is equal to 2 pi over b. If we rearrange that, we will get b is equal to 2 pi over the period, which gives us b is equal to 2 pi over 4, which is pi over 2. And usually we'll leave b as a fraction of pi. We won't actually calculate the value. Because we got the pi key on our calculator. If we want to graph this, we can just put it into our calculator and go b is equal to pi over 2. Okay, so b is pi over 2. So we have calculated A, we have calculated B, we have calculated D. All right, what are the coordinates of the start point? There's the start point. Where is it? 142, right? 1 minute, one x value. The x value is 1 and 42. 142. What's the value of C? Okay, so start point, which I will abbreviate SP, is negative C over B comma D. Okay, get the bracket in there. Which we know the start point is 142. That means that negative C over B is equal to 1. Right? Because that's the first coordinate of the start point. Negative C over B is equal to 1. But we know B. Right? B is pi over 2. So negative C over pi over 2 is equal to 1. So negative C is pi over 2, and C is negative pi over 2. So, little algebraic manipulation going on there, right? We're plugging into the formula. It's negative C over B. We multiply both sides by B in effect. So we could really write negative C is equal to B in this case, right? And then we would get to here next and not have to worry about this line. So forget that. Just do this. So the value of C is negative pi over 2. And generally, again, we're going to leave things in terms of pi if we can. So what's the equation of the sinusoidal function? Well, it's y equals A, which is 40, sine B, which is pi over 2, times x, plus C, in this case minus pi over 2, plus D, which was, what was D? 42. Let's plug this into our calculator. Let's set the window to match the graph that we have, and let's see if we get that graph, right? So if we've done this right, we should be able to duplicate the graph that we have up there on our calculator, right? And we'll set the window appropriately. So hang on, let me just pause and go get. Okay, so here's our calculator. We got the mode as radians. Window, we're going to set to match, whoops, that was second window. Window, we're going to set the window to match what we have here. And let's just move that over. So it's, the x values go from like 0 to 8. So 0. 2. Oh, down. 0 to 8. Scale of 1 is fine, right? Y values go from 0, how high? 82, so let's go 84 maybe. And this thing goes by 2s. That's going to be too many ticks for this window, but whatever. Okay, y equals. So we're going to graph. What was our y equals? So 40 sine. So here's how we're going to enter it. 40 sine pi divided by 2. So pi divided by 2 times x minus pi divided by 2 plus 42. And one other thing I always like to graph when I do this, I like to graph the midline, right? Because that'll help us see, hey, are we really looking at this? And we'll hit graph. And there's our graph, and there's our midline. And does that look like the graph that we were given? Yes, it does, right? Okay. Good, right? So that means if I give you a graph, if you can find the max and the min, you get the D value, you get the A value. If you can figure out the period, you can get the B value as well. Given the start point, you can figure out C. They're not going to ask you to do that, right? But they will give you graphs where you got to figure out either A, B, or D. And we can actually come up with the equation, right? That's the equation, or this is the equation that gives that particular graph. Questions on that one? Okay, do the same thing. Tidal depths. In Inverdeen Harbor, the maximum depth of water is 22 meters. 22 meters. Occurring at 1 a.m., right? So this is a height in meters. Let's maybe just label this to help ourselves out. Height in meters, and this is time in hours. So the values that are affected, or the values A, B, C, D that affect the height or the y value are A and D, right? A and D are measured in meters. B and C are more x-axis units, right? The period is measured in hours. The start point is measured in hours. Okay, so what do we got? 22-meter depth occurring at 1 a.m. and 1 p.m. as shown on the grid below. The minimum depth of water is 6 meters occurring at 7 a.m. So let's go to 7 a.m. and 6 meters. And 7 p.m. What's 7 p.m. in a 24-hour clock? 19. The depth is 14 meters at 4 a.m. Okay, 4 meters at 4 a.m. Or sorry, 14 meters. 14 meters at 4 a.m., 10 a.m., and 10 p.m., which is what on the 24-hour clock? 22. Assume the relation between the depth, water y, and the time in hours of the sinusoidal function. On the graph, in which t equals 0 is midnight, plot the key points listed above, connect the points to form a sinusoidal function. Okay, so we seem to have these four things, right? This goes from 1 to 7. 1 to 7 is 6 hours. Half of 6 is 3. So this is the midline. The midline is going to be at 14. So I'm going to draw that in. Also, we have a maximum, right? So here, let's do this. So D is equal to max plus min over 2, which is 22 plus 6 over 2. So D is equal to 14. So this is my midline. Its sinusoidal happens in 4 parts. In this case, we're going from the maximum to the middle, from the middle to the min, from the min back to the middle to the max. This will be one complete period, right? And we want to sketch it out sort of sinusoidally. And then I think I'm missing one of these. 4 a.m., 10 p.m., 4 p.m. I missed 4 p.m. There we go. This will continue backwards this way like this. And this will continue forwards like that. Right. So the tides are going to keep coming in and going out on that regular cycle. So we calculated the midline. The amplitude, A, is max minus min over 2. Okay, or it's 14 to 22, right? Which is 8. So from 14 to 22 or 14 to 6. You can just count it, right? 2, 4, 6, 8. 2, 4, 6, 8. But you can also calculate it. So max was 22 minus 6 over 2, which is 16 over 2, or 8. State the period. How long does it take to repeat? Well, you can go from a maximum to a maximum, right? 7 a.m. to 7 p.m. is how long? 12 hours. So the period is 12 hours. And the start point, what's the start point? Where's the start point? Stop me when I get to the start point. Here, 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 here. Stop me now. That's the start point. So when you reach the midline and you're going up, that's the start point. So the start point is 10:14, right? Start point here abbreviated as SP is 10:14. Okay, we got A and D. A and D are nice, they're easy, they stand for nice stuff, right? I mean, midline, but period doesn't give us B, but allows us to calculate B. So we've stated all of these. Now we need to calculate B and C to get this equation in this form, which we will then graph, set our window to this, and see if we got it right. Right? So you can always verify this, right? When you're figuring out what's the equation of a graph, verification is plug it in, see what you get. Okay, period. So we got some work to do, right? We know the period is 2 pi over b, which means b is 2 pi over the period. So b is 2 pi over 12, which is pi over 6, right? And we're just going to leave that. We'll enter it into our calculator as pi divided by 6, okay? And everybody will be happy. Calculator will be happy. We'll be happy. And we need the C value. So we know the start point is 10:14. So we know that the start point is negative C over B comma D, right? We already know the D is 14, so we're interested in negative C over B is equal to 10. So let's go negative C is equal to 10B, right? Just multiply both sides by B. Different eraser. So negative C is equal to 10B. So C is equal to negative 10B. So C is equal to negative 10 pi over 6. Okay. We could reduce that. It would be negative 5 pi over 3. Let's put it all together. Set our window, go into our calculator, enter this, and see what we get. So we have y is equal to a, which is 8, sine pi over 6, bracket x, minus 5 pi over 3. Another couple of brackets, plus, and what's d? What is d? It's off there. 14, I think. Okay, let's go to our calculator. Turn it on. I'm going to clear out this stuff. So our midline was 14, right? So I'm just going to put that in as y2. y1 is 8 sine. You can put brackets if you want, but you don't need to. So pi over 6, second pi, divided by 6, x, minus 5 pi divided by 3, bracket, That's good, plus 14. We need a window. We want a window that's going to match the window that we have here. So let's go 0 to 24 by 1, 0 to 24 by 1s, that's our times, and 0 to, how high does this thing go? 28 by, what do we got there, 2s? Yeah. Okay, so 0 to 28 by 2s, graph. Does that look like what we got? Pretty much, right? So we could find the max, right? We know the max is at 1 and 22. So if I'm looking for this max, I can go max. I go second calc. Number 4 is maximum. Well, let's do this one here. This should be 19 and 22, right? Or 13 and 20. Oh, we're this max. They didn't give us that one. 13 and 22. Okay. Yeah, but that works, right? Because the period is 12 hours. What did we do? Oh, we did minimums, right? To figure out our period, we went from here to here. 7 a.m. to 7 p.m. So if I want that minimum, we could verify that minimum. Second calc minimum 3. And let's go to this minimum down here. Oops, wrong curve. Enter. Go around the corner. Enter. Back up. Enter. That should be 19 and 6. 18.999998 is 19, right? So 19 and 6. So everything matches up nicely, right? There's a question. To figure out the period, how much of the graph do you have to see in order to calculate the period of the function? Like, do you need to see this whole part here? You need to see that to that to that? What if you only saw from here to here? Would this be enough to calculate the period? Yeah, because you could say, well, you've gone from a max to a min. That's half the period, right? Max to midline, midline to min. That's half the period. If I know what half the period is, so in this case that would be from 1 to 7. So if half the period is 6, what's the full period? 12. Okay. Do we even need that? What if we got from here to here? Is that enough to calculate the period? Yep. Yeah. What fraction of the period would we have? 4. 1/4, right? So this is 3. It's a quarter of the period. So then the period is 12. Right? So you don't need to see a full graph. You do have to know that this is a max and that that's the midline, right? So you need to see at least a quarter of a period in order to calculate the period. Right? And then you'll just know. Okay, we got a number of functions here. Match each graph with one of the equations listed. Now, this one's going to be in degrees. So let's just start off by finding A. What's A? Actually, sorry, let's find D. D is equal to max plus min over 2, right? What's the maximum? 3 plus negative 1 over 2, which is equal to 1. So we're looking for a 1. There, there, there. Oh, and there's cosine graphs too. Okay, we need more information, right? The 1 isn't enough, but let's figure out the amplitude. So this will be max minus min over 2, which is 3 minus negative 1 over 2. And how much is 3 minus negative 1 divided by 2? Okay, so this one's out now. So it could be this, could be this. Now, it's always good to draw in the midline. So period-wise, there's no difference between this function and this function, right? They both have a b value of 1, which makes the period 2 pi or 360 degrees. In this case, 360 degrees. So it comes down to start point. The start point, this is a sine function. It starts at the middle and goes up. So this is b. Okay, if you remember a cosine function, we played with those a little bit the other day. They start up at the top. They start here and go down. So this graph would have to look like this to be a cosine function, right? It would start at the top and then head down. All right, let's clear some stuff off. Let me word. All right. Next one. What's the amplitude? Forget about calculating. What is it? Just count it. Okay, sorry. Let's start with D. What's D equal to? What's the midline? 1. What's the amplitude? How far is it from here to here? Half. Okay, we got 1, we got a half. The only thing with an amplitude of a half is A. Right? So the question, how far do we need to go? Well, as far as we need to, right? We don't need to go any further. There is nothing else with an amplitude. There are no other 1/2 for an amplitude, right? We could check it out. 1/3 x, so the period is 2 pi over b. So now this is back checking that this is the correct answer, right? So we'll figure out the period of this equation and see if it matches our graph. So period is equal to 2 pi over 1/3, which is 6 pi. Or because this is in degrees, it'll be 6 times 180, which is 1080, and this period is 1080. Okay, because it's in degrees. Now we've got 2 in radians. Where's the midline? We don't even need to calculate this, right? We just got to count 1, 2, 3, 4. Midline will be 2, 1, 2. So there's D is equal to -1. A is equal to 1, 2. So can I find a 2 and a -1? A 2 for A and a -1 for D. Or sorry, is that a positive one? Positive one. Nope, -1. Oh, did I draw the line in the wrong? So I can't count is what you're saying. 1, 2, 3, 4, 5, 6. Never mind. Good one. I don't think I can erase on this. Not that one. Oh, here we go. All right. So if you could actually count 1, 2, 3, 4, 5, 6. 1, 2, 3. So the midline is at -2. D is really -2, and A is 3. Okay, what have we got with a 3 and a -2? So we've got this, we've got this, and we've got this. So the difference between any of these three will be the period, right? They all have different values of B. So what's the period of this thing? So if we start at the middle and come back to the middle, we can see the period is pi. And B is equal to 2 pi over the period, or 2 pi over pi. So B is equal to 2. And so H is the answer for that one. Right? They're never going to give you this on a test, right? Because all you have to do is graph each one of those and then see which graph matches which, right? Keeping in mind that these guys will be in degrees and these guys will be in radians, right? You set your scale and you set your mode and where you go. All right, so we do a better job counting. 1, 2, 3, 4. 4 is, so 2. So D is -3. A is 2. The period is 2 pi. So the b value is 1. So we're looking for a is 2, b is 1, and c is -3. And the only thing there is e. Okay, so given an equation here, or given the graph of a sinusoidal function, you should be able to match it up with its equation.